Good day, ladies and gentlemen. Welcome back to yet another exciting episode here by Electronic Engineering. Today we're going to get a look and feel of this device which we call the audio generator. The audio generator is a device that generates audio. Now what is audio? Audio is exactly what you are listening to. My voice. That is sound. Generally frequencies between 0 Hz and up to about 20 kilohertz if you are listening to CD music. But you will notice that this instrument can go up to 1 megahertz. And the reason for that is audio actually have harmonics and it's got alternative frequencies that is combined as you make the music. For that reason, vinyl music on vinyl plates is much nicer to listen to than CD music. I'm just saying. The unit consists of a couple of sections. The first one is this big rotary dial in the middle. You'll notice there's a little triangle there that allows me to know where the dial is pointing to. So if I turn the dial, I can go on this machine from 10 to 100. Isn't that nice? So that represents a range of frequencies. From 10 to 100 adjustable. So if I want 25, I will simply go and turn until I get the triangle lined up with the 25 and voila. If I want 150, is that possible? 150? Aha, well done. It's definitely not possible because 150 is not on the scale. There is only up to 100. So, ladies and gentlemen, how do we solve this problem of 150? That brings me to the second part of the range. We have got something called frequency range. Times 1, times 10, times 100, times 1,000, and times 10,000. So, if I want 150, I should then go to 15. 15 times 1 is 15. 15 times 10, that is 150. So 15 times whatever the selector is here will give me my resulting frequency. So the range dial plus the range scale gives me my result. You are going to do a lot of experiments on 1 kilohertz. 1 kilohertz can be set up by a 10 times 100. 10 times 100 is 1,000. Alternatively, one can put the big dial onto 100. 100 times 10 also gives me 1 kilo ohm. Which one is correct? Both is correct. We prefer the 1 times 100 for one reason. It gives me a bit more accuracy when I'm adjusting for 1 kilohertz. Because I can fine tune the big dial until on the oscilloscope it will show me 1 kilohertz. So to recap these two parts of the instrument, the big dial tells me my value, 20. The range selector can do that. So 20 times 10,000 is 200,000 and that would be my result. If I go to 100, times 10,000, I get 1 megahertz. And that, ladies and gentlemen, is how the first part of the equipment works. It has a waveform selector switch. When it is in, it is a square wave. When it is out, it's a sine wave. And the idea of that is to present our circuit that we are building in the experiments with a very clear and precise frequency so that we can do all kinds of nice measurements with it. How small will my signal be? That is adjusted by something called the amplitude and the attenuator. From mathematics, you will remember that if something is 0 dBs, it means it is full strength. The amplitude can be adjusted to whatever level I want. In this case, I want it maximum, or I can turn it back and get minimum, but here I can adjust the amplitude. We prefer to have a strong signal and then attenuate that signal. Now the scale is given in decibels. Attenuator means it reduces your amplitude that is going to come here by the output. It will reduce it. So at 0 means whatever is the maximum or the output voltage here is not reduced by anything. But if I go minus 10, it will be reduced. Minus 20, it will be reduced even more. Minus 30 means 30 times smaller than before. The scale here is dBs, which means it's logarithmic, but more about the advanced reduction of these settings for now. At this stage, keep in mind that whatever my output is, I can through a simple click do division into my amplitude. For instance, if I have 0 dBs and I adjust here for 30 volts, I can have 3 times less, which means 10 volts, or 3 volt, 1 volt, 100 millivolts, and then 30 millivolts. So it can go very small. The beauty is I don't need to touch my amplitude. I can simply use the attenuator to make it less. And my waveforms will be clear. We're going to have a demonstration video following this training. Thank you very much.